But let's back up, start over again, make sure we all understand what's going on. This is a guaranteed test question. So we're back on our notes, problem D, page 14. And we've got this piece of paper that is 12 by 14. And we are going to cut corners out that are little squares, and we don't know how big they are. But we discovered yesterday by making our own boxes that the size of those squares determines how big the box is going to be, right? So what we hope to be able to do is to find the size of the squares that will leave me with the biggest box possible. We call that maximizing the volume. So, yesterday, we recall that the volume of a box is found by what formula? Volume of a box. Exactly. Length times width times height. So we looked at our situation and we said, okay, the length of the box, and it doesn't matter which one you call length and width. I don't want to get into a conversation about that. It's totally irrelevant. One of these is length and one of them is width. That makes a difference. So if I have 14 be the length of the box, no, the length of the paper, then what would be the actual length of the box? Remember, you're cutting these out and folding those flaps up. So what would be the actual length of the box? 14 minus 2x. And in fact, every time,
Was it bonus in the quiz?
there was. What was the bonus on the quiz?
1 + 1.
From now on, you gotta get here on time if you want the bonus. All right, so 14 minus 2x. And we said no matter what size the paper is, it's always gonna be that minus 2x, right? Because you're always gonna be cutting a corner off each one. All right, so what's the width of the box?
12 minus 2.
12 minus 2x. And what's the height of the box? Always, the height of the box is going to be x. So there was your equation for the volume of your box. You don't need to multiply it out. Certainly you can. And in calculus class, when you're doing this problem by hand, it might be easier to multiply it out before you get started. But if we're using a calculator, leave it be. Domain. This is extremely important, guys, because it's going to help us set up our window so that we can see what we need to see in the calculator. Domain is the values of x that make this problem reasonable. X couldn't be 100, for example. Why can x not be 100? That just doesn't even make sense, because why? Because the paper is only 12 long. And if it's only 12 long and you're cutting a chunk off each end, obviously you can't take 100 off of 12. So what is the most you can take off? 6. 6 is the most you can take off. Whatever you take off, whatever you take off has to be less than 6. Why did I erase the or equal to?
Because you can't 0.
Exactly. If I took off exactly 6 from each side of this 12, then I wouldn't have anything left to make a box out of, right? So whatever I cut off has to be less than 6. Here's what I mean. Some of you are staring at me. If I took 5 off of each end, then I would have 2 inches left for the flap. If I took 3 off of each end, I would have 6 left over for the flap. If you took 6 off each end, you wouldn't have anything left for the flap. And you have to have something if you're going to make the box. So it can't be or equal to, it has to be less than. Now notice, I'm focusing on the 12, not on the 14. I have to look at the smallest dimension, right? If I'm taking less than 6 off, I'm going to be okay with the 14. But if I take off less than 7, it won't work for the 12. So I have got to use the smallest dimension. Also, whatever x is, it has to be bigger than 0. Obviously, I can't cut off -2 inches. So however big x is, whatever the x value is, it's got to be bigger than 0 but less than 6 in this problem. Always bigger than 0, always less than the smallest dimension. Okay? Now, get out your calculator. If you don't have one, get out your calculator. If you don't have one, look at a friend's. You'll have to have one for the test. So you may certainly rent one if you want to. I'm not going to require you to rent one today, but and we are going to graph we are going to use the same skills that we used before, but this time we won't be looking for, I'll get you changed in a minute. We wouldn't be looking, we're not looking for the intercepts, the zeros, we're going to be looking for the maximum. So let's type in this equation to go to y equals, and you need to put the parentheses. So for parentheses, 14 minus 2x, 12 minus 2x, and x. So you're going to type in the equation just like it looks, just like this. Now I want you to go to your window. When we graphed before, we were looking for x-intercepts, and we very often use a standard window. You're never going to use a standard window in a box problem. That's why it's so important you set up your domain. This tells you x-min is 0, and x-max is 6. So I'm going to put 0 in for x-min, 6 in for x-max. Windows in the top row of buttons, right here. Okay, now your scale, just leave as 1. We're not going to alter those probably ever. So just leave that scale at 1. Now what about y minimum? 0, very good. Because y represents the volume, and the smallest the volume can be is 0. You can't have -8 cubic centimeters, right? It's got to be bigger than 0. So y min is always going to be 0 in a box problem, because it's always going to represent volume. Now what about y max? I have no idea. That's what I'm trying to figure out, right? The maximum volume. So take a guess. I'm going to guess 200. I'm just taking a guess. Nothing more than a flat out guess. Now I'm going to hit graph. Oh, it's a great guess, because what I have to see when I hit graph is the top of the hill. Let me show you something. Go back to your window and make it 100. Is it clear to you that's not big enough? When you put in 100 and you press graph, what happened? You saw it go up and you saw it come down, but you never saw the top, right? When you are finding the maximum, you want to see the top. So 100 wasn't big enough. So I'll go back and put my 200 back in. Sometimes you're not going to guess it on the first time. I got lucky, guessed it on the first time. But sometimes you're going to have to try a couple of things. Keep guessing until you see the top of your hill. Now we're going to find that point. Okay, now has everybody got this picture?
Yeah.
Okay, we're going to find that point. So we're going to press our good friend second calc. And remember before we picked 0? Well, now we're going to go down and pick maximum. And then your cursor should pop up. You want to set it over here to the left. Hit enter. Move it over here to the right somewhere, anywhere over here. Press enter. And then move it to the top, somewhere in the middle there, and press enter. And it will give you the maximum, 2.1475 and 160.5837. That, I rounded, obviously, but that is your maximum point. This is your X value, this is your Y value for your maximum point. Okay? So what does that mean? That means that if you wanted to make the biggest box possible, you should cut out corners that are this big. And if you did that, you would create a box that had a volume of this. This is the volume. This is the volume. This gives you the size of the corners. So make sure you answer the question. Find the maximum volume of the box. So what are you putting down as the answer to part C? 160.59 square, oh no, cubic inches. That is the volume of the box. Easy enough? All right, there's one more just like it. Let's try E. This time our piece of paper is 20 by 24. And you're cutting out the corners again, just like before. And you gotta write an equation for the volume. Can you do this? What is the formula or the equation for the volume of this box?
20 minus 2x.
Very good, Emma. Times?
24 minus 2x.
Yep, times. And I'll just say, after doing this for so many years and grading so many papers, sometimes kids forget this. Remember, when you're doing volume, you need length, width, height. So you gotta have three things times each other. What?
When you put it in the graph, do you have to have the parentheses or the X?
No.
Okay.
Now, what's the domain here? This is important because if you can't figure out your domain, you're gonna have issues with your window.
6.
The domain gives you the window.
4.
So here we go.
10.
I'm going to be between, X is going to be between 0 and what number? Half the smaller one. So in this problem, it will be 10.
Okay.
So we're going to go to our calculator. We're going to put in a new equation. That's another mistake. Sometimes kids forget to change the equation. You got to change the equation. So 20 minus 2x. 24 minus 2x and x. And then our window now, keep in mind this is x min and this is x max. Whatever domain you have put in, those are your x's. What did I tell you about y min? Always 0. Minimum volume 0. Now, guess. I still have the 200 in there, so I'm going to go ahead and hit graph. I have a feeling it's not big enough. When you graphed it, you saw it go up and you saw it come down, but you can't see the top. So let's change that to, what do you think?
3,000.
3,000?
9,000.
1,000? All right, 1,000, let's see. Oh, 1,000 worked. Now, is 1,000 the only number that will work? No, there are lots of numbers that will work, right? Anything works as long as you see the top of your hill. Okay? So now, second calc. Maximum. Left bound. Right bound. Guess. My point is 3.62774.16. I rounded off to the nearest 100.
Yeah.
Is that what you got? So again, I know what question's asked here, but sometimes the question says, how big are the corners you should cut out? If that's the question, your answer is 3.62 inches. But if the question is find the maximum volume, The answer is 774.16 cubic inches. Everybody okay? The box problem.
Cake.
Cake. Awesome. All right, F. Find the final cost of a sweater that originally cost $52.50 if it's on sale for 25% off and there is a 7% sales tax. Okay, we talked about this yesterday. This is cake. This is cake. You're going to type in some numbers on your calculator and you're going to have the answer. So let's start with the $52.50, and I'm going to multiply it by a 25% discount and a 7% sales tax. So if it's a minus 25%, I'm going to multiply by 0.75. If it's a plus 7%, 1.07. And I type it in and I am done. So 52.50 times 0.75 times 1.07, $42.13.
Will we get that wrong if we don't put the dollar sign?
Yeah, put the dollar sign. All right, here we go. Find the cost of your restaurant meal if the food costs $23.12. Start with that number. And there's a 7% tax. And there's a 15% tip.
Plus 1.07.
So we're going to times by 1.07. Very good.
Times 1.1.
And 1.15. Beautiful. You're getting the hang of it. Here we go. 23.12 times 1.07 times 1.15. $28.45. Is that what you got? Yes, Mrs. Ford, that's what we got. All right, now we got one more kind of problem here that we need to look at. How much 12% lemonade should be mixed with 18 gallons of 20% lemonade to get lemonade that is 18% lemonade? This is called a mixture problem. And when you do a mixture problem, did we do these already this year? Why do I think we did these already?
Not this year, no.
Not this year? I know you've done them before.
Yeah.
I thought maybe we've done it. But we're going to take amount times percent plus amount times percent, and that's going to equal amount times percent. So here's what I want you to do. I want you to simply write this formula right there in the answer, in the space, right? Amount times percent plus amount times percent equals amount times percent.
Is that middle one times or plus?
They're all times. That's plus.
Okay.
It's amount times percent plus amount times percent equals amount times percent. What's happening is you have something that you are adding to something else and you're coming up with a final solution. So the first thing we're mixing is 12% lemonade. So I'm going to go through and I'm going to put in all my percentages. So I have a 12% lemonade that I'm mixing with 20% lemonade to get 18% lemonade. So does that make sense to everybody? The final mixture is the one over here by itself. So I'm mixing the 12%, the 20%, and the 18%. Now, do I know any of the amounts? I know one of the amounts. It tells me that I have 18 gallons of the 20%. So the first thing I want you to do, especially as you're just getting used to these problems again, is to fill in all the numbers that they give you. Now, if you do that, there will always be two blanks. one of those blanks is going to be X. Which one do you think is going to be X? Read the question.
Next to the 8.
Right here is X. How much 12% lemonade? How much 12% lemonade? Right there. Now, what goes over here? Well, that's the total amount of lemonade that you have. You can put Y, but then you'll need another equation, so you might as well just recognize that what would Y have to equal? X plus 18. Think about it, kids. You've got a big bucket here. You're dumping in X gallons of the 12%, and then you're dumping in 18 gallons of the 20%. So how much would you have at the end? X plus 18. If you put in 30 gallons and 40 gallons, you'd have 70 gallons, right? Well, we're putting in X and 18, so this is just going to be X plus 18. How much? 12%. That's why that's X. This is X plus 18 because you added these two together. That's what you're doing. You're adding these two together to get the total. All right, so now we're going to solve it. It's a regular little equation. We'll solve it. You have a calculator. I'm going to do that on the calculator. Now this seems nuts because that's like a first year algebra equation, but sometimes we miss it because when we subtract this from both sides, which is, I hope what you're going to do, what do you get right here?
0.6.
No, that's the mistake that's made.
Negative point.
No, it's not negative.
0.06.
It's 0.06. Now, you're going to have a calculator, so if there's anything about the arithmetic that you think, oh, I don't trust myself, use your calculator. But that's 0.06 when we subtract. And what do we get?
0.36. And it's actually 6.
So that's 6. And my unit is gallons.
Wait, whoa.
6 gallons.
I think I missed something.
You divided by 0.24,
Yeah, just subtract that. Just solving a little equation, you have to subtract it. Alright, luckily we've got another one. Let's look at I. You don't have to write this down every time. I will, because I want to get the problem right. But you basically have amount times percent plus another amount times percent equal to amount times percent. Okay, that's what we have. Let's fill in all the percents first. So we got a 22% sugar solution. And we're mixing it with a 74% solution. And we're going to get a 50% solution. Does that make sense to everybody? Okay. Now there should be at least one other number that you know. We know 100. And the 100 is an amount. And it's the amount that goes with the 50. So the 100 goes over here, right? Now once again it says how much 22% solution. So that's going to be my X. Now, before, in the last problem, we had this blank. This was the other blank that we had. And we got x plus 18 because we were adding these two amounts, right? We were adding these two amounts to get that one. Okay, so I'm over here now. I am adding these two to get that one, right?
Minus 2x.
I'm adding these two to get that one.
Yeah.
So for a minute, let me call that y. I am adding x and y to get 100.
Yeah.
So tell me what y is. 100 minus x is what goes in there.
Why would,
Okay, well then I didn't hear you. But so, if you are filling in this blank, it's going to be an add, because that's how you get that number. You add these two to get that. If you're filling in one of these blanks, then it's going to have to be a subtract, because that's the total. So these are going to be less than the total. Right?
Right.
All right, well, here we go. We got 0.22x plus 74 minus 0.74x equal to 50. So how many x's do I have over here? Negative 0.52x. Keep an eye on my arithmetic. Was gallons again. Was my arithmetic okay?
Where'd that 74 come from?
You distribute right here. So 0.74 times 100.
Okay.
Remember, once you get it set up, it's just like a regular old equation that you solve. Okay. All right, we're not going to do the last two in the notes there because we're just a little lagging behind. So we're going to skip that, and instead we're going to grab our practice test.
So the graphing practice sheets.
We already did we did some of the graphing practice. We're getting out the practice test. The thing that says practice test now. We're getting ready. Getting ready.
The one that says 1.5.
Yep.
That looks very familiar.
There you have it. And the front of it does look a lot like your graph practice. Here's a staple. See that? For some of you, it might be stapled. It depends if you're absent or not when I handed them out. Ready?
It's stapled.
Yeah, it's probably that, but it's stapled.
Right here.
Oh.
So it might be stapled to your graph practice, and it might not be. They were handed out the same day.
Yeah, mine's stapled.
So what I would like to do is turn to the back of the front page, and we are going to do these word problems right now. Okay, so we'll get the whole test done, but we're going to do the word problems first because we just want to practice a little bit more with these. All right, so let's see how you can do with number 2. This is the box problem.
Oh yeah, I love box problems.
How are you gonna do with your box problem? What are you gonna say?
Let's set it up.
Okay? So how big is the paper? 13 by 9?
Yeah.
All right, so what's the formula for your volume, or the equation for your volume? Here we go.
13 minus 2x.
13 minus 2x.
9 minus 2x.
9 minus 2x.
And then x.
And then x. That is our formula for cutting the corners out of the box. Is everybody okay with that? We are on practice test 1, the back of the front page. All right, what is the domain here for this thing? Are you on the right page? What's the domain? X is between what?
0 and 4.5.
0 and 4.5. Perfect. 0 because it's always 0. It's got to be positive. And 4.5 because that is half of the smallest dimension. So now we go to our calculator and we type in that new equation. We fix our window and we see if we can find the maximum. Remember to find the maximum. Once you get the picture graphed, you go to second calc and then choose maximum. Left bound, right bound. Yes. And we've got it. Anybody come up with an answer? What'd you come up with?
1.74991.43.
So then we gotta decide which of those is gonna be the answer to the question. It says, find the maximum volume of the box.
91.
So the answer is 91.44 cubic inches. Is there anyone that's got a question about that? Andy, I know it's a rainy morning, but we gotta sit up straight. We're happy to be here. Everybody okay with the box? All right, next, find the cost of your new uniform pants. If the price tag says $33.50, there's a 15% discount and a 7% tax. So here we go. You're gonna take $33.50 and do what with it? Multiply it by 0.85. That's a 15% discount. And 1.07 because that is your add-on tax. So $33.50 times 0.85 times 1.07. Did you get $30.47? Did you get 468?
Yeah.
Okay, then you got 47. All right, now we got another mixture problem. So let's see if you can figure this one out. Amount times percent plus amount times percent equals amount times percent. So there's 6 things. Okay, so what do we know? Matthew?
I put x times 0.45, and then I did 32 times 0.75, and then x plus 32 times 0.58.
All right, so this part takes absolutely no skill whatsoever, right? This part, we're just plugging in all the numbers that they gave us. Now, Matthew says that he put an X here. That makes perfectly good sense because it says how much 45% cocoa. So X is going to be the answer to that question. And then down here, he put X plus 32. Does that make sense? Yes, because where is that coming from? Adding these two together. So X plus 32 is going to be the total. Emma?
Yeah.
You got it? Okay, all right, let's solve it. Here we go, let's solve it. So we have 0.45x plus 24 equals 0.58x plus 18.56. So just doing some straight multiplication and some distributive property. Do a little rearranging, moving things around, so X is by itself. I got 41.85 ounces. What about you?
Yes.
We'll do one more of those in a minute, but let's finish this page. Let's get this page done. Last year, the team won 19 games. This year, they won 24 games. What is the percent of increase? So one way to do percent change, percent of increase, any change, is to take the difference and divide it by the original. Well, the difference is 5 and the original is 19.
26%.
So whatever that is.
26%.
So they won 26.3% more games. That's an increase. So 26.3% increase is the answer to the question. That's all there is to it. All right, now there's a little bit of room probably at the bottom of your page. I want to do one more mixture problem. Let's say how much 24% solution should be mixed with 40% solution to get 50 gallons of 30% solution. How much 24% should be mixed with 40% to get 50 gallons of 30%? Okay, so for just filling in our percentages, we have 0.24 here, 0.40 here, and 0.30 here. That's easy. And then there's one other number we usually know, and in this case it's 50, and that goes with the 30.
Would it be X of both of those?
No. Both of them are unknown,
50
but you
minus
can't call them both X, because if you call them both X, it implies they're the same amount.
So Y.
You can call one of them Y, but then you have to have another equation, because you can't solve it if it's got two variables in it.
X
So
plus X.
I would suggest that you think about it like this. If you want to preliminarily call that Y, what do you know about X and Y? X plus Y has to add up to 50. So really, this isn't y, really it's what?
50 minus x.
50 minus x. A little bit ago, I told you that if your unknown is over here, if your empty parentheses is over here, it's always going to be these two added together. If your unknown is over here, on this side of the equal sign, it's always going to be these two subtracted. These two have to add up to this one. These two add up to that. So if you remember that concept, these two add up to that, then you'll never have any trouble filling them in. This is the total. This is one of the two pieces. Okay? All right, how much time do we have? Not much.
3 minutes.
Let's see how much graphing on the front page we can get done, and then we'll finish that next time, finish this practice test next time. So, on the graphing, this is like the quiz you just took, but it's also a page of the test. You have to do this on the test. This is what your test is going to look like. I have a page just like this. So, let's get the first one done anyway. What do we do with negative 2f of x?
Multiply by the height.
What?
Multiply by the height.
The height is multiplied by 2. And it's a negative, so it's going to go, Brooks is back there going like this. It's going to go upside down. Okay? So in the original, your picture is a little triangle and a bigger trapezoid. So the little triangle is going down 2. So now he's going to go up 4. Now why is he going up? Because he got turned upside down. Why is it 4? Because it was originally 2, and we are multiplying by 2. Now the trapezoid is originally going up 3. So he is going to go down 6. So there is our trapezoid. So that's the answer to the first question. All right, I've packed a lot in. We need to have one more quiz.